Plucked from the trash, everyday objects are destroyed, then transformed by technology, reborn into modern marvels. Bicycles are the main ingredient inside Dutch ovens. Juice cartons are squeezed into decorative wall panels. And water bottles find new life as sportswear. These are the things that are made by destruction. In Amsterdam, everybody rides a bike. With over 880,000 bikes, 70% of all trips in Amsterdam are made by pedal power, which may account for the rush hour bike jams. So it's no surprise that after all that pedaling, thousands of bikes are scrapped every year. Now, an enterprising Dutch company has cooked up a way to send these sideline cycles to a brand new destination. The workers at Tradeform turned bike frames into an important ingredient in classic cookware. Steel bicycles are recast into Dutch ovens. To pull off the transformation, salvagers and metal workers sort, cut, and melt the steel frames to turn them into cast iron. In order to reclaim the frame, the first step is to break the bike down. A worker moves a bike into the factory for dismantling. Steel is a principal ingredient in making cast iron. The worker is only looking for the steel bike parts not plated with chrome, which will pollute the cast iron. The worker suspends the bike on hooks to make it easy to gut. Another worker removes the chrome-plated wheels. Then, he uses an angle grinder to slice off the pedal arms and crankshaft. A bolt cutter snips the chain in pieces. Finally, he yanks out the chrome-plated handlebars and seat post. Nothing's left but the diamond-shaped pure steel frame. A worker pulls it from its perch and tosses it in a bin. These bikes are ready to move on. The foundry of Lovink Technicast BV in Terborg, Netherlands, takes in thousands of bike frames, mixes them with steel scrap, and melts them into cast iron. In destruction step 2, the steel bike frames are melted down. A grapple magnet pulls up a load of bike parts. Airlifts it across the foundry and lets it go over an induction furnace. Rather than using external heat, an induction furnace melts the metal from the inside out. A strong magnetic field causes eddy currents within the conductive steel to generate intense heat. The steel begins to liquefy at about 1,400 degrees Celsius. A foundry worker steers a ladle filled with molten additives to the mouth of the furnace. Turning steel into cast iron means upping the metal's carbon content from 0.2% to 4%. This is achieved by adding high-carbon scrap like automotive brake rotors and silicon to the steel alloy. Cast iron retains heat and maintains its shape in high temperatures, making it ideal for casting and for cooking. After 90 minutes, the bubbling cast iron flows down a channel to the bottom of the two-story furnace and collects in a large crucible. A forklift moves the molten iron to its casting session. Bicycles have been stripped and smelted, bringing them one step closer on their journey from the street to the stovetop. The molten iron is cast, coated, and assembled into high-end cookware. In the Netherlands, salvage techs and foundry workers rescue abandoned bicycles, break them up, and melt them down into liquid cast iron. Now foundry workers will recast the molten metal into cutting-edge cookware for Dutch oven manufacturer Composite. The first step is to create a sand mold to cast the Dutch oven. A worker loads a steel pattern into a vertical molding machine. Inside the machine, a mixture of sand, clay, and water is blown into the sealed chamber. With 8 kilopascals per square centimeter, hydraulic arms squeeze the mix against the forms, compressing into the exact outline of the Dutch oven. The clay bonds the sand together. The machine ejects the mold onto a conveyor. In creation step 2, the liquid iron is poured into sand molds. The molds pass under an automated pour machine. Hot metal pours into the sandy cavity. The cast iron conforms to the shape of the pot. The molten molds travel along the line, taking about an hour to cool down. The sand cake pots move into a shaker that rocks and vibrates to loosen the sand. Workers pull the still warm ovens from the conveyor belt and load them onto a suspended cooling rack. An operator steers the rack filled with newly minted Dutch ovens to the cleanup station. The rack glides into the shot blast machine. Heavy metal doors close behind it. Inside, high-pressure blast wheels fire tiny ball bearings called shot, bombarding the cast iron, knocking off the residual sand and scraping away any imperfections. The pots exit with a dull sheen and a clean, uniform surface. A worker clamps the oven onto a CNC machining center that carves a shallow cavity into one side. This will house the temperature gauge once the pot is complete. The ovens are now ready for a coat of enamel. A worker sprays the pot with a misty slurry of powdered glass called vitreous enamel. This coating seals the porous cast iron to keep the oven food safe. It won't burn, won't rust, and is easy to wipe clean. The oven bakes at 750 degrees Celsius to cure the enamel coating. A worker dabs the hollow on the face of the oven with glue, then inserts a thermometer and lines it up. Finally, he screws a knob onto the lid. This Dutch oven is ready to get cooking. Cookware manufacturer Composite has diverted and converted abandoned bicycles into long-lasting Dutch ovens. Craftsmanship and creative thinking forged a new life and found a new home in kitchens around the world. And that's a recipe for success. Juice cartons keep drinks fresh for months, but recycling all the multi-layered packaging is a challenge. Now, a forward-thinking company in Des Moines, USA has figured out how to repurpose all those flattened cartons. Rewall Solutions takes in mountains of discarded juice cartons and reconstructs them into building materials used to cover walls, ceilings, and as exterior sheathing. Juice cartons are remade into decorative wallboard. To build the wallboard, recyclers shred, compress, and layer the sheets into multicolored composite panels. Juice cartons are made of up to 6 layers of stiff paper board, sandwiched between an aluminum layer and a plastic coating. These materials provide structural strength and insulation in a wall panel. A truck backs a shipment of juice cartons onto the loading dock. A forklift ferries 1-ton bales of flattened post-consumer cartons into the factory. A worker snips the bale wire. The loose cartons tumble onto the floor. A front loader scoops up a pile of cartons and shovels them onto a belt, which feeds them into a grinder. Blades shred the layered paper, low-density polyethylene, and aluminum liner into 4 to 5 centimeter chips. The chips drop onto a conveyor. Discarded juice cartons have been squeezed, shoveled, and shredded to bits, ready to be rebuilt into trendy wall panels that turn any room into a room with a view. The shredded cartons are steamed, pressed, and cut into composite wall boards. Recyclers at Rewall Solutions offload bales of post-consumer juice cartons and shred them into chips. A conveyor with raised rubber treads sweeps up the shred and carries it to a hopper. The juice carton chips drop onto a leveling table, sandwiched between 2 sheets of Teflon paper. Twin rollers guide the loose shred into a 3-stage hydraulic press. The first press densifies the material, packing it down from 12 centimeters to 2 centimeters thick. Steam melts the polyethylene, which acts like hot wax to meld the paper and aluminum chips together into a composite sheet. Another press blows cool air onto the sheet to chill and set the wax, which solidifies it into a stiff composite board. Once it's cooled, the sheet rolls off the press. The Teflon paper peels away, exposing a 2.5 meter width of brand new paneling. Finally, the composite wallboard slides into a jig that holds the sheet in place and guides the saw blade. A worker uses a circular saw to cut the panels into sheets. He stacks them on a skid. It takes 800 shredded juice cartons compacted together to produce one panel. Before the wallboards can be installed, they need their edges trimmed. A worker feeds the sheets into an automatic panel saw. Clamps hold the sheets steady while a computer-controlled arm with a saw on the end makes clean, even cuts on all 4 sides. A forklift stacks the sheets, ready to ship out to construction sites across the country. Discarded juice cartons have been shredded, compacted, and cut into long-lasting, moisture-resistant panels. And the splatter of colored flecks turns affordable wallboards into abstract art. Proving that juice cartons don't just keep drinks fresh, they keep ideas fresh too. Bottled drinking water is cheap and convenient. Uncap it, take a few sips, then toss it away. We produce enough plastic bottles to generate a ring around the world 2,500 times over. The good news is, advances in technology are able to transform water bottles into new products that are changing the fabric of the fashion industry. A company in Reedsville, USA is taking in tons of plastic bottles and remaking them into a new material that's taking on the competition. Plastic water bottles are knit into sports shirts. At Unify's sprawling plant, recyclers shred, melt, and extrude plastic bottles to turn them into a recycled polyester yarn called Reprieve. The first step in the destruction process is to sort the recycled plastic bottles. A forklift loads 600 kilogram bales of the plastic bottles into a bale breaker that feeds a separator. In the separator, sharp metal edges tear away at the labels while dirt and debris fall through the holes. Next, laser scanners detect the bottle's color and density. Precision air jets launch the colored plastic into a separate bin. Only clear plastic is suitable for making the white recycled polyester yarn, which can then be dyed or printed. Churning hot water soaks off the rest of the paper and flushes away any remaining debris. Workers pick over the bottles, removing any colored plastic or litter that the sorting machine may have missed. The conveyor shuttles the bits of clear, clean polyethylene to a grinder. The grinder granulates the plastic into 13mm sized flakes. The flakes propel through a friction washer and dryer and pipe into shipping sacks. The plastic flakes land at Unify's factory in Yadkinville, USA, where it'll be turned into recycled polyester yarn. A forklift carries the 680 kilogram super sacks to the extrusion line. A worker unties the bag and unleashes the flakes into a hopper. The flakes are pushed through the machine by a heated screw, which liquefies the polyethylene. The auger forces the molten plastic through a die plate, which shapes it into long strands. The 10mm thick molten filaments discharge into a water trough, which cools and hardens the plastic. The strands flow under the knife of a chopper, which cuts them into 5mm sized chips. The chips air dry and tumble through a grate. Powerful fans channel the chips into storage silos. Each silo holds about 27 million recycled plastic bottles. Cast-off water bottles have been reduced to tiny plastic beads that will be transformed into wearable, comfortable clothing. The plastic chips will be knit into yarn, woven into fabric, and styled into sportswear. Recyclers have sorted and cleaned discarded plastic water bottles, ground them into flakes, melted into strands, and chopped them into polyester chips. In creation step 1, a second extrusion process transforms the chips into thread. The 5mm sized chips flow from the holding silo into an extruder. They're heated to 300 degrees Celsius and are melted down. The auger pushes the plastic through a die plate to form 50 filaments of polyester, only 20 microns in diameter. Winding machines wind the filaments together onto a tube of partially oriented yarn. The yarn spools into large rolls. A robot shuttle grabs the roll and transfers it to the texturizer. Texturizing draws and twists the fiber, adding strength and giving the recycled polyester yarn a more natural feel. The yarn reels onto cones and is prepped for packaging. An army of transport robots and a highway of automated assembly lines can process 10,000 packages of yarn a day. The next step in the process is to turn the polyester yarn into fabric. Contempora Fabrics in Lumberton, USA knits polyester yarn into a flexible, resilient fabric that's tailor-made for activewear. A textile worker places packages of yarn on a creel. He feeds that yarn into a guide tube that threads an average of 1,500 needles in a circular knitting machine. As the machine spins, the needles create millions of stitches, knitting the yarn into rolls of polyester fabric. Contemporary's 200 circular knitting machines output over 900,000 kilograms of fabric a month. A worker wraps the rolls of polyester to be shipped to the clothing manufacturer. Vapor Apparel in Union, USA combines ultra-modern methods and old-world craft to cut, print, and sew polyester into stylish sportswear. In creation step 3, a technician uses a process called sublimation printing to transfer a perfectly scaled color graphic from the screen to paper to fabric. A printing machine prints a design onto a large piece of transfer paper using an ink developed specifically for this process. Workers lay the paper onto a roll press. Then, they stretch a sheet of polyester fabric on top. Rollers pull the fabric, transfer paper, and a sheet of blotting paper through the press. Pressure and 190 degrees Celsius heat convert the ink into a gas, which infuses the polyester fibers. A worker watches the process to make sure the transfer is flawless. The printed fabric winds onto a reel, ready for the last step in its transformation: sewing. At a cutting table, a worker uses a wheeled blade to cut out the printed polyester pieces. All that's left to do is to put them together. At the sewing station, a seamstress gets to work. It takes a 6-pack of plastic water bottles to produce this bold, breezy polyester sports shirt. Combine an endless supply of discarded plastic with imagination and high-tech machinery, and you get a line of trendy, well-priced activewear. A water bottle wardrobe that's a perfect fit.